Hey, David. All right, so I circled all the questions I think you were asking about. So I'm going to start from the top. Question 20 on page 364. Okay, so use a calculator to evaluate the following. If you typed in 10 of 0, you would get 0. If you typed in 10 of 90, you would get math error. You get no solution. Now it's asking us to think about this. Why is this true if we think about a triangle? Well, using the ratios. So we know the tangent ratio is opposite over adjacent. Now, if the angle was 90 degrees, like this, and we try to use the ratio, look what happens. Tan of theta is opposite, which technically becomes our hypotenuse, over adjacent. Now the problem is, which side is adjacent? They are both technically adjacent to my 90 degrees, isn't it? So because of that, 10 of 90 is not possible. No solution. Now 10 is 0. So if we think about a triangle, okay, we have a triangle, and let's say we're looking at an angle of 0 degrees. Well, what happens is this line, the hypotenuse, will eventually, in order to meet the criteria of 0 degrees, this would have to overlap, which means we end up with a straight line, don't we? Well, if we end up with a straight line, then we have an angle of 0 degrees. So then tan of 0 degrees would just be 0, okay, because it wouldn't exist. Opposite, there will be no opposite side, would there? Now, this is a preview for grade 11. If you were to graph tan theta or tan x on Desmos, you get a graph like this. Okay. Now, what I want you to notice is the fact that at x equals to 90, look at our graph. It never touches 90, does it? It gets close to it, but if you zoomed in, you will realize it never touches the blue line, ever, because there's no value that exists there. And if you look at tan 0, you get an answer of 0. Okay, so this represents the tan graph. In fact, if you remember from our classroom, at the very back, you will see a bunch of posters that represent the sine graph, cos graph, and the tan graph. Okay? They're periodic, which means they repeat. These functions repeat themselves, as you can see. Now, if you were to graph every single point, so tan of, let's say, 45, or tan of 48, you get an answer of 1.11. Tan of 59.7, you would get 1.711, and so forth. Okay. Now that's just a little side note that you will learn next year in grade 11. Okay. What was the next question you had? I don't know if it was on this page. Maybe the next page. Okay. So, number 8. What height above the ground do the wires intersect? So, the fact that you asked me this question, I'm assuming you figured out question number 7. Okay. Now, question number 7, we've got a shape like this. Okay. Now, the easy thing to do here is to break them down into two separate triangles. So we've got 15 here, 6 here, 15, 6, and over here 8 and 6, 8 and 6. Okay. Now, for question 7, your job was to find these two angles in here, which represent these two angles here. Okay. Now, I'm not going to go ahead and solve these angles. I'm assuming you could do that. But once you figure out these angles in here, whatever they turn out to be, and how would you solve these? Well, if I look at this, and let me backtrack. How did I get 10? I got 10 simply by using Pythagoras. 6 squared plus 8 squared equals 100. Square root of 100 is 10. Same thing here. Okay. Now, to find this angle, all I need to do is identify opposite, adjacent. So I need to go tan inverse, or sorry, let's just go tan theta, forget the inverse, equals opposite over adjacent, and then theta will equal to tan inverse of whatever 8 over 6 is, and that will give you this angle, okay, which will give me this angle in here. Okay. Anyway, so once you find those two angles, this is the tricky part. Our job is to find sorry, I can't see. Okay. Our job is to find this height, right? Now, this is the tricky part. Although we have these two angles, so if I look in here, all I know is that this is 6 degrees, or sorry, 6 meters, and I know these two angles, okay? I know these two angles. My job is to find this height, right? Because question 8 is asking for, where'd it go? Question 8 is asking for, at what height above the ground do the wires intersect? So they intersect here, which is here, so we need to find this height. The problem is, if I look at this triangle, even if I know these two angles, I don't have another side to work with, right? Because once I have one of these two sides, so for example, let's say I find this side right here, let's call this x, then I will be able to find this height. Now, if I look at this, and I would be able to find this height. Sorry, I got sidetracked. The cat's meowing. If I look at this 6 is actually going to end up being useless. And the reason being is because we don't know if this 6 will be split exactly in half. And we cannot assume that it will. So this 6 is essentially useless. So I need to find at least one of these two sides in order to use SOHCAHTOA. Okay? Now, 1 second, sorry. Okay, sorry about that. Now, so where was I? Right. So we need to be able to find this side or this side. Okay. Now this is the tricky part. So this question was very tricky. In order to find one of those two lengths, we need to realize that this triangle here and this triangle here are actually similar triangles. How do I know that? Well, I know that because by angle, so I know this angle is the same as this angle, and by the Z pattern, because they use the word parallel in here somewhere, two vertical poles, the level, okay? Level, so which means this is completely flat, which means this angle in here would be the same as this angle in here, okay? Which means that if I were to draw this triangle and overlap it with this one, okay? So if I flip this, then I know I can compare the side of 15 to 8, 15 over 8. Now I'm going to label, now this might be a little confusing, label this as x, and label this as 10 minus x. Why is that? Because if I look at this triangle, it is the same as this triangle, isn't it? Which means at some point here is where they intersect. So if I'm going to label this as x, then the rest must be 10 minus x, right? Now why did I do that? Well, I did that because if I were to picture this triangle flipping over to here, so this line and these two lines will overlap, so we'd have 15 over 8, and x, this, will overlap with the 10 minus x. Okay, so once we have this equation, all I need to do is solve for x. So I cross multiply 15 times 10 minus x equals 8 times x. Solve for x to get 6.52. Which means I'm essentially done because this little triangle in here, okay, or in other words this little triangle, if I redraw it, would mean I have an angle of a side length of 6.52. Some angle in here, which you have found here in 7a. Then I use SOHCAHTOA to find this height. So this question was very tricky. I'm hoping I did not assign this question. This question would be much easier to explain in class because there are so many steps. But hopefully I addressed all of them, and hopefully you understood. If not, send me an email to clarify. Number 12. This question, okay. Let me just double check what the numbers are like. Level 18, been blocked, 80 degrees. Consecutive levels are 10. Okay. So I know that that's 10, and that's also 10. And Lucy can leap 12 meters. Okay. So a question like this, it's asking us if Lucy will make it across here. Okay. I know the most she can leap is 12. So our job is to find this distance. If we find this to be less than 12, she'll make it. If we find this to be more than 12, she won't make it. Okay. Now the fact that I know that that's 10 and that's 10 makes it easy because I know it's going to be two right angle triangles. Okay. And my job is to determine, and because that's 80, and because that splits it perfectly in half, and how do I know that? Because that's 10 and that's 10. I know that angle is 40. I know that angle is also 40. So in this right angle triangle, I have a 40 degree angle there, 10 across there, solve for x, using 10 in this case. And you want x to hopefully be less than 12. Okay. And was that it? No, there's more than that. Oh, right, there's two more down here. Okay. So our job here is, this is the net. Okay. Now, if I just highlight this part represents the top of the octahedron, and this part represents the bottom. Okay, which means that if you picture this one in the middle, if you fold these ones around this one right here, this will represent the top piece. Fold these three around this one, this will represent the bottom. So our job is to find where that blue line is, the distance between those two. So how do I find that distance? Well, it's the same thing as finding the length. Now, these are equilateral triangles, right? So if I just drew out one of the equilateral triangles, I know that that's 20, 20, 20. My job is simply to find that height. Okay? And because it's an equilateral triangle, I know three angles in a triangle add up to 180, which means this would be 60, 60, 60. Okay? Now the fact that I know that's 60 and I know that's 20, that should be enough. This triangle in here, I know that angle is 60, I know that side is 20. Our job is to find that height. Once I do, multiply it by 2, I'm done. And 23. Okay, so our job is to find what? The angle right here. Okay, so to find that angle, our first job is, I know that this is 147. So I need another length, either this edge here or this bottom. Okay? But it sounds like this bottom would be easier to find, this length. Why? Because I know that if I go exactly 90 degrees to this, 90 degrees, I know that this distance here would be half of 230, which would be 115, and I know this distance would also be 115. How do I know that? Well, because of this is a square base pyramid. Okay, so now this is 115, this is 115. I can use Pythagoras, 115 squared plus 115 squared, to find this length. Once I have this length, and I have this length, I can use my tan ratio to find this angle. And, oh, right. This question here, so 22, I'm pretty confident there is a mistake in this question. And I'll tell you why. So, we've got ourselves a bridge, okay, 140 meters. One person stands here, looks down at an angle of depression of 41 degrees. Another person stands here, looks down at an angle of 48 degrees. Our job is to find this height. Now, yes, we are given the fact that this is 140, but that's not very useful because we don't know that it's split down the middle. The only way we know that's split down the middle is if these angles are both 45. Okay, but they're not. So it does not split it down the middle. Well then, what can we do? In Unit 8, or in Chapter 8, you will learn something called the sine law and the cosine law, which will help us solve triangles that are not right-angled triangles. Because if I look at this, I don't see a right-angled triangle anywhere. Well, sorry, I lied. I do see one right here, and right here. Okay. But in either triangle, all we have is an angle. We don't have a side length. We don't have one there. We don't have one there. We can't assume. We know it's 140 for the whole thing. I guess you can say this is, let's call this x, and let's call this 140 minus x. But that's all we got, isn't it? And if I wanted to check to see if these two triangles were similar, they're not, because this would be 42, and this would be 49. So none of the angles are the same. 90, 90, that's the same. Let's double checking to see if there's anything. If I looked at the big triangle, so if I looked at the big one, that means this is 41, that is 48, and this would be 91, right? To make that 180. And no, even if I looked, I was thinking maybe if I look at the big triangle and compared it to one of these small ones to see if they're similar, I don't see a similarity there either. So I think there is a mistake in the sense that I think that the 41 was supposed to be a 42. Because if this was 42, then this angle in here, this right here, would be a perfect 90 degrees, which will make this a right angle triangle, which will make it possible to solve. Okay? But in this case, there is no similar triangles anywhere. You don't have enough sides, so you can't really solve this question without using one of these two laws, which you learn in Chapter 8. Okay. Once you learn Chapter 8, you should be able to come back to this question and solve this no problem. If we were to assume that this was close enough to 90, if we assume that this is close enough to 90, then yes, we could solve it, because then we can use the 140 that's up here, and if that's 90, then I could solve this side length, right? So if I solve this side length, I will have, or let's call this y, sorry. We can find that, and then we can use SOHCAHTOA to find this height. Okay. So hopefully that answers all your questions. And sorry, I looked at the answer in the back of the book. It said that this was 68. So if you were to assume that it was close enough to a 90 and assume this is a right angle triangle because it's 91, and you did what I just said there, using SOHCAHTOA, using 140 to find this length of y, and then using this y to solve for the height, you would get 68. Okay. So two things. Number one, maybe the textbook made a mistake. It was supposed to be 42. Or this question is wanting you to assume that anything close to a 90 is good enough for you to use SOHCAHTOA, which I don't completely agree with. Okay. Anyways, hopefully those answers your questions. If not, let me know. Take care.